Hey there, good evening, subscribers on YouTube and Fidevil. Jonathan here. We are working with LT Spice. In particular, we've been working with series resistors and parallel resistors in the past, in the previous videos. I wanted to move on and introduce, since we worked on capacitors earlier, we're going to be going over this chapter with first order circuits. And by first order circuits, it means by a first order of derivation or derivatives, excuse me. So if you're familiar with derivatives from calculus or pre-cal, like such as d over dt or d dt, it basically means that there's a rate of change happening. There's a rate of change happening. And in this example, we have both a capacitor and a resistor in parallel. Not two resistors in parallel, but a capacitor and a resistor in parallel, with an initial condition of a voltage source. This happens to be sourceless, so there's no voltage source, but you do have an initial condition of a voltage source. And then the switch disconnects. Either the switch connects or disconnects. In this case, it's going to disconnect because it's sourceless voltage. And then we're going to be working with some of these formulas, seeing if we can work backwards and solve for the plot and the making sense of this discharging circuit, because RC circuits in this case have a discharging time because the capacitor acts as a battery almost. The capacitor acts as a battery, and then it discharges through the resistor through heat. It dissipates through heat, right? So over here, you can see this is a C1 and this is R2. Let me rename this to R1, actually. R1, so we don't get confused. C1 and R1. C1 is a 10 microfarad, or 10. This is a mu in Greek, and it means 10 to the negative 6. 10 microfarads, and then 10K, which is 10 times 10 to the third. So then essentially these magnitudes will affect each other. So we have an IC of V of VA. This node is VA, V sub A, or V lowercase a, which is a 5. I placed it as 5 volts as the initial condition. I haven't been able to get the ideal switch to work in this circuit, but using this formula, we've been able to substitute for a switch. And then we're going to do a transient analysis, since discharging happens over a step response, or stepping down from a voltage source, a positive voltage source, to 0, or any other discharging to 0. So transient is 500. I placed 500 milliseconds. That's about half a second, or it is half a second. So we're gonna run the simulation, but of course I wanted to go over the formula. It might be a little bit confusing for some that have not gone over the calc series or differential equations. But you have V of 0, initial condition, equals V sub 0, and then you derive the equations for voltage, current through a capacitor, which is C times dV of dt, which is the change in voltage. Don't let that scare you. Remember, anytime you see dV or di over dt, dV over dt or di over dt, it's the change in voltage, or it's the change in current. So again, don't let it scare you. It's just the change in voltage or the change in current. And then we can work backwards to integrate or differentiate to find the rate of change or to find the area under the curve, which is the how much voltage has been dissipated over time. And then at the end we see V. This is with the initial condition of V sub 0. V of t is equal to V sub 0, our initial condition, times e to the negative t over RC. E is a natural number, 2.11, etc. It's just the nature of how this circuit discharges. So, don't let the fancy formulas scare you. It is a little bit daunting. It is a little bit. It can look kind of scary at first, but don't let it scare you. It's just a formula. And we as we say in the courses with some of my old classmates, plug and chug. So I'm going to run the simulation, and then we have the simulation window over here. This is the transient window. I'm going to expand this so that we can see a little bit clearer. And then I'm going to add a trace here, and then we're going to do V of VA. And then we've already done the work here with the initial condition .IC V of VA equals 5 volts, or any volt. It could be 10 volts, 12 volts, and transient of 500 milliseconds. So then if I click OK here, you can see this this beautiful discharging curve. This is the e to the negative t over RC. E to the negative t, e to the negative infinity. If t over RC, as time increases to infinity, the discharging circuit goes closer and closer to 0. Don't let it scare you. It's only seeing things in going towards negative infinity or positive infinity. And so this is exactly what we are observing in our own curve. This is the voltage response of the RC circuit. It looks like a slope. It looks like a half pipe for many of the skaters out there. Tony Hawk, pro skaters, anyone? It looks like a half pipe where you can skate up and So anyway, I think it's a beautiful curve. Maybe that's a nerdy thing to say, but I think it's incredible how beautifully mathematics works out sometimes. So I hope that makes sense. If you have any questions, please do ask.